Today we are going to talk about the second method in solving the system of linear equation. The method is called substitution. It's a very simple method. In previous lesson we talked about solving system of linear equations using graphing, and then in the graphing technique we said that you can graph the two lines either using the table of values, or you can use the x, y intercepts to plot the lines, or slope, y intercept, and the last one was using technology. So there were four different ways of plotting the two lines and then investigating the graph to find the point of intersection. We said in that lesson that the solving system of linear equation using graphing is not the best method. The problem is first the time it takes to plot the two lines, and also the point of intersection is not going to be precise. There are cases that you will see in this lesson that the solution is going to be fraction, and using graphing is not going to give you exact solution. So what is the other technique on solving system of linear equation? This technique is called substitution. It's a very simple technique. What the method says is that to substitute one variable in the second equation from the first equation, isolate one variable and then put it back in the second equation and solve the second equation for the variable. And then you can go back to either one of the lines that you have, equations that you have. You can evaluate the other variable. The method is easily understood with examples. So let's start doing a few examples. The first example says that you have two lines that they intersect at right angles. Find the coordinate of the point of intersection. Let's first see if really these two lines are perpendicular to each other. To do that one, I'm going to write the second equation in slope y intercept. So the first equation is y equal negative x plus 8. The second equation, I'm going to take negative y to the right, change the sign, and 4 to the left. So I'm going to get y is equal to x minus 4. Now looking at the slopes here, the slope of the first one is negative 1. The slope of the second one is positive 1. And you can see that these two slopes are negative reciprocal of each other, or the product is negative 1. Negative 1 times 1 is negative 1, so they are perpendicular. Now let's try to find the POI of this system of linear equations using the substitution technique. The technique says the variable y here is negative x plus 8. The variable y here is x minus 4. So this means that this one, the right hand side here, negative x plus 8, and the right hand side here, x minus 4, they have to be equal because both of them are equal to y. So I can write negative x plus 8 is equal to x minus 4. I'm going to bring negative x to the right and negative 4 to the left and change the sign. So I'm going to get x plus x, negative x to the right becomes positive x, is equal to 8 plus 4. So 2x is equal to 12. So x is going to be equal to 6. Now I have x. How do you find y? Just pick another equation one of these two and then evaluate y. So I'm going to say the first equation, y is negative x, so it's negative 6 plus 8, which is going to be 2. So this means that POI is 6, 2. Now always remember to check the equation to see if POI satisfies both equations. The first equation says y is equal to negative x plus 8. Let's put y is equal to 2 and x is negative 8. If y is 2, so this is 2, this is a question mark, we don't know if they are equal. X is 6, so it's negative 6 plus 8. Negative 6 plus 8 is 2. 2 is equal to 2, so that's correct. Now try POI in the second equation. The second equation says y is equal to x minus 4. So again, y, question mark, x is 6 minus 4, which is going to give me 2, so 2 is equal to 2, so everything is set. The second example is asking us to solve the system of linear equation x plus y is equal to 5 and 3x minus y is equal to 7. So what I'm going to do is that I'm going to find x in the first equation and then put it back in the second equation to find y. So from the first equation I can say that x plus y is equal to 5. I move y to the right, so I get x is 5 minus y. Now I put this x back in this equation, the second one. So I'm going to say 3, open bracket, x is 5 minus y, minus 7 is equal to 7. Now distribute 3 inside, so 3 times 5 is 15. 3 times negative y is negative 3y, minus y is 7. This gives me 15 minus 4y is 7. Now I'm going to bring negative 4y to the right and 7 to the left. I get 4y is equal to 15 minus 7, which is going to give me 8. Divide by 4, I get y is equal to 2. Now pick again any one of these equations, the first or the second one, to find x. Better than this one, we have the third equation, which is already changed. X is 5 minus y. So I'm going to put y equal to 2 in the third equation and find x. So using this equation and this value, I get x is 5 minus 2, which is going to be 3. So I found that POI is 3 and 2. Now let's check to see if this is correct. The first equation says x plus y must be equal to 5. Now x is 3, y is 5, so, 2, so I get 3 plus 2, which is going to be 5, which is great. The next equation says 3 times x, so 3 times 3, because x is 3, minus y minus 2 is 9 minus 2, which is 7, which is correct. Let's do example 3. The question is, where do the lines 2x minus 4 and 4x plus 9 intersect? Meaning, what is the point of intersection? So again, I have the equation 2x minus y is equal to 4 and 4x plus y is equal to 9. Again, what I'm going to do is I'm going to try to isolate one variable. Let's say, looking at these two equations, you can see y doesn't have any coefficient beside it, so it's better to isolate y. So from this equation, I can find that y, if I move y to the right and 4 to the left, I get y is equal to 2x minus 4. Now I put this one back in the second equation for y. So I get 4x plus y, which is 2x minus 4, is equal to 9. I move negative 4 to the right and change the sign, so I get 4x plus 2x is 6x, is 9 plus 4, which is going to be 13. So from here I get x is 13 over 6. Now I'm going to put this 13 over 6 back in this equation to find y. So I'm going to get y is 2x, so 2 times 13 over 6 minus 4, which is going to be 2 cancels with 6, gives me 3. So I get 13 over 3 minus 4. To change the denominator to 3, so I multiply by 3, divide by 3. I get 13 over 3 minus 12 over 3, which is going to give me 1 over 3. So my POI is 13 over 6 and 1 over 3. Now, just imagine if I wanted to solve this one using graphing. It is very hard by investigation to see that x is 1 over 3, which is 0.333, and y is 13 over 6. This is an example that exact solutions like substitution technique is much better than graphing method. Again, you are advised to check the solution, meaning put it back in the equation and then see if this is correct. The last example here is a word problem. It says that Stephanie has 5 more fish in her aquarium than Brett. The two have a total of 31 fishes. How many fish does Stephanie have? How many fish does Brett have? Let's say x to be the number of fishes which Stephanie has, and y to be the number of fishes that Brett has. We know that they have a total of 31, so I can write that x plus y is 31. That's the total number of fishes. We also know that Stephanie has 5 more fish in her aquarium, so this means that x is y plus 5. Now I have two equations, a system of linear equation. I know x is y plus 5, so I'm going to substitute x back in this equation and find y. So I'm going to write y plus 5, which is x, plus y is 31, y plus y is 2y, and I'm going to bring 5 to the right, change the sign, which is going to be 26. Now I'm going to divide by 2, and I get y is 13. So this means that Brett has 13 fishes. Now I use y equal to 13, sub it back in this equation and find x. So x is y, which is 13 plus 5, which is 18. So this means that Stephanie has 18 fishes and Brett has 13 fishes. Let's check the answer. First of all, 13 plus 18 is going to give me 31, which is correct. And also, 18 is equal to 13 plus 5, which proves that the second equation also is satisfied by this POI.